Today, we are going to introduce the Bus Expert 2, a professional testing and debugging tool specifically designed for eMMC 5.1 and SD 3.0 technologies. The B2's versatile features are built to handle a wide range of testing needs, making it an essential tool for engineers when testing storage devices. Not only is the B2 an efficient and precise professional testing tool, but it also comes with a rich set of features. It can meet basic testing requirements, and with its advanced analysis modes, it helps users quickly identify and resolve issues. The product positioning of the B2 is very clear. It's specifically designed to meet the testing needs of eMMC 5.1 and SD 3.0, providing solutions for high precision and stability. As storage technology becomes increasingly complex, traditional testing tools struggle to capture the protocol details accurately, and that's exactly where the B2 comes in. One of the core advantages of the B2 is its dual-mode design, combining both a logic analyzer mode and a protocol analyzer mode. This allows for simultaneous signal timing tests and protocol analysis. The all-in-one design eliminates the need for frequent device switching, significantly improving testing efficiency. Additionally, the B2 is equipped with high-precision signal measurement probes and calibration fixtures to ensure measurement stability and accuracy. Designed specifically for eMMC 5.1 and SD 3.0, the professional probes minimize signal loss and accurately reproduce real signal waveforms, providing engineers with reliable data. The trigger function is another highlight of the B2. It offers dedicated trigger options for eMMC and SD, allowing for precise capture of specific commands, data, or protocol events. This makes it easier for engineers to quickly pinpoint the root cause of issues, especially when dealing with large volumes of data, greatly enhancing testing efficiency. Advanced analysis features, such as command classification, quantity statistics, and packet sorting, are also key highlights of the B2. These features automate data analysis and generate detailed reports, making it easier for engineers to evaluate results and smarten up the testing process. In summary, the B2 focuses on stability, ease of use, and precision. Whether it's in hardware quality, software functionality, or operational convenience, it strives to deliver optimal performance. This design makes the B2 the ideal tool for engineers, significantly reducing testing cycles and improving test accuracy. Next, let's take a look at the standard components of the Bus Expert 2, B2, which together form a complete testing system, ensuring that users get accurate results in various testing scenarios. First, we have the main unit. The B2 main unit supports 32 channels of signal measurement, which means it can capture up to 32 different signals at the same time. This allows users to not only observe the primary signals but also monitor other related signals associated with the test object. This is especially useful when performing multi-channel synchronized measurements or analyzing complex circuits with multiple signal interactions. Next are the active probes, which are another key component of the B2. These high-precision probes are designed to minimize interference with the test object and reduce signal distortion. Compared to passive probes, active probes have a higher frequency response, capturing finer signal changes, making them ideal for high-speed data transfer testing environments and ensuring the accuracy of the signals. In addition, the calibration fixture is an essential part of the B2. Its main function is to calibrate the trigger levels and I/O delays, ensuring the accuracy of the test results. As data transfer rates increase, even small delays or level shifts can impact the test results, so the calibration fixture ensures that the B2 maintains stability and consistency in precision testing. Overall, the B2, with its main unit's multi-channel support, active probes for high-precision testing, and calibration fixture for accurate calibration, offers a powerful and reliable testing solution. Now, let's go over the software installation process for the Bus Expert 2, including the basic system requirements, software download, and installation steps, to help users quickly set up and start using the device. First, there are some system requirements for installing the B2 software to ensure compatibility with your operating system. B2 supports multiple Windows operating systems, including Windows 7, Windows 8, Windows 10, and Windows 11. We recommend that users check their computer's system to make sure it meets the requirements, to avoid any compatibility issues during the installation process. Next, let's go through the software installation steps. You can download the B2 software from the official Zero Plus Technology website. Simply go to the technical support page on their website, which can be found at http://www.zeroplus.com.tw/logic-analyzer_n/technical_support.php. On this page, you'll find the latest version of the B2 software. After clicking to download, save the file to your computer and then proceed with the installation. Next, let's go through the detailed steps for installing the B2 software, to help users successfully install and activate the Bus Expert software. Before you start the installation, it's recommended to close any running programs to avoid conflicts that might interfere with the installation process. The B2 installation file is typically downloaded as a compressed file. So, before you begin the installation, you'll need to extract the files. After extracting, you'll find all the necessary files, including the main installation file. Once you've extracted the files, go to the folder and double-click the setup.exe file to start the Bus Expert software installation process. When the installation interface appears, select the Application Setup option, which is the main part of installing the Bus Expert software. This step will guide you through installing the application components. During the installation, you'll be prompted with a license agreement. Please read it carefully, select Accept to agree to the terms, and then continue with the remaining installation steps. Next, let's go through the detailed steps for installing the B2 software, to help users successfully install and activate the Bus Expert software. Before you start the installation, it's recommended to close any running programs to avoid conflicts that might interfere with the installation process. The B2 installation file is typically downloaded as a compressed file. So, before you begin the installation, you'll need to extract the files. After extracting, you'll find all the necessary files, including the main installation file. Once you've extracted the files, go to the folder and double-click the setup.exe file to start the Bus Expert software installation process. When the installation interface appears, select the Application Setup option, which is the main part of installing the Bus Expert software. This step will guide you through installing the application components. During the installation, you'll be prompted with a license agreement. Please read it carefully, select Accept to agree to the terms, and then continue with the remaining installation steps. Next, please follow the steps below to complete the installation process. After the Bus Expert software is installed, the system will prompt you to install the necessary driver for B2. This driver ensures smooth communication between the B2 device and the software, and guarantees stable data transmission. Simply click the Install Driver button as prompted. Once the driver is installed, you don't need to restart your computer. You can immediately launch the software and start using B2. This provides a faster and seamless installation experience. You'll find the Bus Expert software icon on your desktop, and you can open it to begin the device setup and testing. After completing these steps, you'll have successfully installed both the software and the driver. The B2 device should be detected and ready to start data measurement and analysis. The no restart installation process makes it more convenient, saving time and improving efficiency. After completing the software installation, the next step is hardware setup. Here's the specific process and key points for setting up the B2 hardware. First, let's connect the B2 device to the computer. Check the ports on the back of the B2 main unit. These include the power port and data connection port. Follow the steps below to ensure a correct connection. Use the included blue USB 3.0 cable to connect the B2 to your computer. USB 3.0 provides stable, high-speed data transfer. Make sure to use this cable to ensure the best transfer speed and reliability. Plug it into a USB 3.0 port on your computer for optimal performance. Use the included black DC power supply to connect the power cable to the power socket on the back of the B2 main unit. This power supply provides stable power to the B2, ensuring that the device operates reliably even during long periods of use. After completing these hardware connection steps, please double-check each connection point to make sure everything is securely in place. This will ensure that the B2 device is properly connected to the computer and ready for use. When setting up the B2 hardware, it's crucial to pay close attention to the security of each connection point and ensure the best possible configuration for your testing environment. Here's a detailed hardware setup process and key points to keep in mind. The B2 comes with multiple probes, which are essential for measurement tasks. Note that the probes are divided into 4 different types, A, B, C, and D. Each probe is designated for a specific purpose, and they should not be mixed. For example, probes A and B may correspond to different measurement channels, and using them incorrectly could lead to data errors or inaccurate measurements. So, make sure to check which channel each probe corresponds to before use to avoid any confusion. Connecting the probes is simple. One end should be connected to the measurement port on the B2 main unit, and the other end should be connected to the signal output of the device under test. This allows you to capture the signals from the device under test in real time and transmit them to the B2 for analysis and display. When measuring high-speed signals, it's recommended to attach a ground wire alongside each signal line to improve measurement accuracy and reduce noise. This will help stabilize the signal and effectively suppress interference. Especially when measuring high-frequency signals, the ground wire significantly reduces noise, ensuring the signal's accuracy. After completing these steps, double-check all the connections to ensure that the probes and ground wires are correctly set up. This will allow us to start using the B2 for signal measurement and analysis without any issues. Now, let's go over the order in which you should connect the probes. The main unit of the B2 is where you connect the various probes and external signal sources. Here's how to configure each connection. A0 port, connect probe A to the A0 port. A1 port, connect probe B to the A1 port. A2 port, connect probe C to the A2 port. A3 port, connect probe D to the A3 port. Next, continue connecting the probes following this sequence. A4 port, connect probe A to the A4 port again. A5 port, connect probe B to the A5 port again. A6 port, connect probe C to the A6 port again. A7 port, connect probe D to the A7 port again. And so on. This ensures that each signal line corresponds to its respective probe, keeping the connections clear and organized. Please follow this order when connecting each port and probe. Not only does this help with accurate signal measurement, but it also prevents interference or data errors caused by incorrect connections. This organized approach keeps the system in good order and provides a clear source for the signals when you start your data analysis. In this section, we will go over the use of the calibration fixture for the B2 device. Please pay attention to the following steps. Now, we need to use the calibration fixture to ensure measurement accuracy. The calibration fixture is a specialized tool designed to calibrate the trigger levels and I/O delays of the B2 device, which is critical for high-precision measurements. When performing calibration, connect the USB cable to the same host machine. This will allow the software to automatically adjust and calibrate the test frequency based on the signals provided by the calibration fixture. When using the calibration fixture, be sure that each of its output signals is grounded. This prevents noise interference caused by poor grounding, ensuring the stability and accuracy of your measurements. Proper grounding is essential for reliable signals and accurate measurements. Before you begin hardware setup, make sure all connections are secure, and use the calibration fixture to adjust the test frequency and ensure measurement accuracy. Each output signal from the calibration fixture must be grounded to reduce interference and guarantee stable measurement results. By following these steps, you'll be able to achieve precise measurement outcomes. Let's go over how to perform the preliminary calibration before testing, which is a crucial step to ensure accurate measurements. Preliminary calibration not only enhances the precision of your measurements but also ensures that the system is operating at its best. Here's the detailed process for calibration before hardware setup. First, make sure that the hardware is properly connected and that the calibration fixture is installed correctly. Next, open the Bus Expert software. Once the software is up and running, we'll proceed with the calibration. At this point, ensure that the software has recognized the B2 device and that it shows as being ready. In the software interface, find and click on the sampling menu at the top. From the drop-down list, select Trigger Level Settings. This is an important step in the calibration process, as it will help us set the correct trigger levels for optimal measurement results. Within the trigger level settings, you'll see an Auto option. Select Auto, and the software will automatically complete the calibration process. This will automatically adjust the trigger levels and test frequency based on the current hardware connection and the input signals from the calibration fixture, ensuring measurement accuracy. Performing the preliminary calibration is straightforward, just follow the steps above. Once you've completed the preliminary calibration, you can confidently move on to your testing. This process helps ensure that all measurement parameters are set optimally, preventing inaccurate results due to incorrect settings. In this section, we'll go over the process of calibrating the trigger level and I/O delay. These calibration steps are crucial for ensuring measurement accuracy, especially when performing high-precision measurements where even small deviations can significantly affect the results. Let's go through the steps for both trigger level calibration and I/O delay calibration. The trigger level is an important parameter in the measurement process. It determines when the signal is captured. Setting the correct trigger level ensures that we capture the target signal at the right time. Here's how to calibrate the trigger level. We need to fine-tune the trigger level for each channel to ensure that the signal waveform is accurately captured. This adjustment ensures that the system doesn't miss crucial data or mistakenly capture irrelevant noise as valid signals. To improve trigger precision, we can use the calibration fixture to perform auto-calibration. This process automatically adjusts the trigger levels based on the current hardware setup, ensuring accurate triggering for each channel. Using this tool helps improve the consistency and reliability of measurements. I/O delay calibration is another critical process that helps reduce the offset caused by signal transmission delays between different channels, which is especially important for high-precision measurements. Here's how to perform I/O delay calibration. When multiple channels are running simultaneously, any delay between signals can affect the measurement results. The goal of I/O delay calibration is to ensure that each channel is synchronized, so the signals across different channels stay consistent, improving measurement accuracy. To achieve effective calibration, we need to combine the hardware and software features. On the hardware side, the calibration fixture provides the necessary test signals. On the software side, it automatically adjusts for the delays, ensuring optimal measurement results. After performing I/O delay calibration, you'll notice a significant improvement in signal synchronization and delay control during the testing process, which is essential for high-precision environments. Once the trigger level and I/O delay calibration are completed, these settings will be optimized for high-precision measurement environments. This means that your test results will be more accurate, reflecting the true nature of the signals being tested and reducing errors caused by delay and inaccurate triggering. Through trigger level calibration, we ensure that each channel captures the signal accurately and we don't miss critical data. Through I/O delay calibration, we ensure synchronization between multiple channels, reducing errors caused by signal delay. Using the calibration fixture along with the software's auto-calibration feature helps make the measurement process more precise and stable. After completing these calibration steps, you will be able to achieve reliable test results in high-precision measurement environments.